Hello and welcome to my video about exponential growth and decay. Now before doing this lesson, it's really important that you go back and do the lesson about exponential functions where I talk about y equals a times b to the power of x. Now on this lesson we're really going to be focusing on the b value, which is your growth or decay factor. What's new here is talking about how rate determines that. So on exponential growth functions, the growth factor b is 1 plus whatever rate percentage. Now usually that'll be given as a percent, so you'll add that percent to 1. Just make a note here as well, this is on page 197 in your work text if you have it handy, that the rate would equal b minus 1. That will help with some of our problems coming up. Okay, now exponential decay functions are very similar, except for the key difference that the rate is being subtracted from 1. So our decay factor is equal to 1 minus the rate. Now, the note that you want to add in here is that when it's a decay function, the rate will equal 1 minus b. So add that in, and we'll use that on some of our problems. So I'm picking this up on page 200 in your work text, which is practice B. What I'm going to do is talk about finding the initial amount, which is really easy. Let's go and do that part. If this is my function on number 2, my initial amount A is simply 5.5. That's my initial amount. Super easy, part of the problem. Okay, now we're going to find the rate of growth as a percent. Now since it tells me it's growth, I know that my rate will equal b minus 1. Now that's coming from the notes that we just took. Alright, now the b is 1.5. So it's going to be 1.5 minus 1, which the rate is going to be equal 0.5. Now it didn't tell me to present it as a regular or constant, it said to present it as a percent. So since my rate is 0.5, to represent it as a percent, I can actually multiply it by 100%, and the rate would equal then 50%. If you need to use a calculator, that's fine, but all I'm doing is just moving the decimal to the right 2 places to get 50%. All right, that handles number 2. Now I'm going to go on down and do 6 and 7. This is doing the same thing, except these are functions of decay. All right, first off on number 6, the A, like I said, that's the easiest part. So that's the 1420 that you see at the lead of the function. All right, the R requires a little bit of work. The difference here being is that since this value is less than 1, this is a decay function. So now you're going to use rate equals 1 minus your decay factor, B, which is 0.895. So if you do that in your calculator or by hand, you're going to get 0.105 as your rate. But again, it wants it as a percent, so I'm going to multiply that by 100%. That moves the decimal to the right 2 places, so my final answer here is 10.5%. Now I do want to talk briefly about number 7. First of all, you see a fraction, people panic, but really quick about the a value. Since there's nothing written there as an a value, you can always write a 1 in for it. So 1 is my a value. So usually a is really easy, but sometimes there is a little trick like that. Now I would do the same thing here. Since 3/5 is less than 1, I'm going to be using 1 minus b, since b is a decay factor. So R would equal 1 minus 3/5. Now that's going to end up being 0.4. And again, multiply by 100%. So that's going to be 40%. All right. Now I'm going to go back and do number 5 and then do number 9. And then we got one more thing to look at on this lesson. So on number 5, I'm supposed to just simply write a function that represents the situation. A bee population of 3,000 increases by 40% every year. Now this is growth because it increases. All right, now what I'm going to do is go ahead and make mention that my A value is going to be 3,000. That's the starting amount of the population. Since it's increasing, my B is going to be a growth factor, and if you look back at your notes, B is going to equal 1 plus my rate. So here, B is equal to 1 plus 40%. You're going to see I wrote that as 0.4. Now, 1 plus 0.4 is 1.4. So this 1.4 represents increasing by 40%. Now I'm ready to make my function. Y equals 3,000 times 1.4 raised to the power of x. I think in the textbook they actually use t a lot for time, but that's fine. It just depends on what you define it as. All right, going on down to number 9. This is going to be a decay function because it says decreases. Again, A is really easy to spot usually, so it's 25,000 here for A as the initial population of money, so the initial value of the car. Since we're decreasing, my decay factor B is going to equal 1 minus my percent change, my rate. So 1 minus 0.167. Got a little sloppy on my writing there. So B is equal to 0.833. All right, now that I've got my A and my B, I can make my function. Y equals, A is 25,000 times 0.833 raised to the power of x, which represents that this is decreasing by 16.7% each year. Okay, so back on page 198 now, flipping back a page or two, we're going to actually talk about compounding interest. So what happens is when you invest money, if the interest is, it will build interest. That interest will then build interest of its own once it becomes compounded. Now, to calculate the balance of an account, you use this formula. For my class, you don't really need to worry about memorizing that formula. I'll provide this to you when you do need it. All right, so P is the principal, which is your initial amount, as it says. R is the annual interest rate, so it's plus R, it's gaining percent. T is the time in years, and N is the number of times compounded. That's the new little wrinkle to this. So let me give you some examples. If a problem says that it's compounded monthly, N would equal 12. If a problem says that it's compounded quarterly, N would equal 4. And this is because monthly happens 12 times a year, quarterly happens 4 times a year. And another popular one is daily. That would be 365.25. If you're wondering about the 0.25, that's because of leap years. All right, I'm going to go ahead and use this formula now that you should either write down or be looking at on page 198 to answer number 10, which I'm going to write that formula down. Y equals P times 1 plus R over N raised to the N times T. I'm actually given everything I need to fill in everything except for time here, which is what I'm supposed to be doing. 5,000 is my principal, Y equals 5,000, times 1 plus. Now, the rate comes from the 7.2%. Don't forget, we're going to divide that by 100% to change it to a normal number. So the rate here is equal to 0.072. 0.072 is my rate over, now, here's the new little thing. You got to look at how often it's compounded. This problem says compounded monthly, so N is equal to 12. So it's over 12, close parentheses, raised to the, again, it's compounded monthly, so 12 again for N, times T, raised to the 12T. All right, this is actually the final answer. It is possible for you to be asked at some point to, like, now say for 5 years later, and you'd have to put 5 in for T, but this is all you're supposed to do here. One last thing to reference, on this assignment, you're going to have to do page 199, numbers 2 through 5. If you need help with that, go back to my exponential functions video, which was 003, and look at page 192, 134 that I did in the video or on the notes. All right, folks, I appreciate it. Let me know if you've got any questions. Thanks.